basically this one is the hands-on activity, the PPM and the requirement, what we need to do. And so basically for this hands-on activity, these objectives, we need to understand how is the series, parallel, open circuit and short circuit, how it work. And we need to develop teamwork. So we need to help each other, we need to communicate more about this assignment.
Mm,
So basically this one we need to use Tinkercad. You guys know what is Tinkercad?
yeah, I know about it.
So we need to use that to create a circuit. This one is the question. So you need to use Tinkercad and then you need to use the inside the component like uh, breadboard to create a small circuit. And then for this one we have two part. One of the part is like follow instruction only, and the second part is we need to record and then upload to YouTube. Okay.
Mm,
So for this one, the question, follow the instruction, we have three questions. So for the first one is the series circuit, and then second parallel, and then the third one is the combination of series and parallel. So you guys like one question, one for one people to do, or like we discuss each question like that.
uh, what do you think? What's your opinion or idea?
Um, I think maybe we can do one person, one question.
One person, one question. Okay.
Sakura, yes, is okay. You want A, yeah? Okay. So Yaya, you want which one? I think you can do B.
You want to do B or you want to do C?
I think I can do C.
Okay. I
So
can help you with I can do B and also help you with C if you want.
okay, okay, it's okay. So we are one team, so we can help each other. So let me take a note first. So okay. So basically, you guys can see from the instruction like simulate the circuit in figure one, using nickel car, and then measure voltage and current for each resistor. So you just follow the instruction inside that, and then for B, which is Yaya, what you need to do is when you create this one parallel circuit, and then you want to measure for the voltage and current. Okay, but uh, in the end, before you end your question, you need to adding the resistance in series and parallel, and adding the battery, and compare both of these. What is the different based on your operation. So I think for this one, we can write in the report. So for report, I think we not that so fast to do it first. Okay, you can just like jot down or what is your observation, but don't need to do the report first. Okay.
Okay.
Okay, just a moment. Okay. So so for questions here, I will do it. And okay, so can take note. So for the deadline is 17 November okay, which is
Mm,
before our programming test. I think.
okay.
Okay, so okay, below is the hands-on rubric. So for communication, we need highly efficiency about our communication. And then for contribution, we need to help each other. We need to carry out assignment and support other. Okay, this one is
Mm,
basically to get a high mark. Okay, and in time management also very important since we have a lot of tests between this. Okay, so this about this hands-on activity. You guys have any question?
no questions.
No question. Okay. So Sakura, you have any question? Okay. So, anything else you want to share your opinion or what?
Uh, Currently, I don't know.
Okay, now mind. So, okay, you guys have any question or any things you don't know about the Tinkercad? Okay, just ask for the YouTube to have the tutorial first, and then you guys really don't know. I think you can put on your question in the WhatsApp group, since we have a WhatsApp group already. And
Yeah, okay.
also, I think after the ECA test, I think we can straight away have the solution already. I mean, like the which is the circuit we have done already, and then what is the observation of this. Okay, report just don't take it first, so we can like do for the circuit first. Okay.
Okay.
Okay,
Okay.
so if you guys have any question, then you can ask in the WhatsApp. Okay.
Okay.
Okay, so I think that's all for now. Okay. Okay.
Okay.
Okay.
Yeah.
Thank you guys. Okay, have a nice day.
Bye.
Okay, bye. Okay, so we can start now.
uh, just explain about my circuit, right?
Ah, yeah.
Alright, so hello. Okay, so now I will discuss about series circuit. Okay, so as you see, the part one, I already do a Tinkercad. By using Tinkercad, make a series circuit, and as you see, the current same but different voltage because uh, in series concept or theory, current is same. Okay, next, when we double the power supply, which is we increase from 12 to 24 volts, you can see that voltage and also current also increase. And next, when I put another resistor, which is 25 ohms, you can see the current still same, but we have a different voltage by each resistor. Alright, so the next part is uh, when when I place a wire across one of the resistor, the resistor is not detect the voltage, but another one can detect the voltage. Okay, the last one is when I remove one of the resistor, which is open circuit. Mm, the we get the voltage same as the power supply, which is 12 volts. Okay, that's all.
Okay.
So, can Yaya, you explain your part?
Yeah, I will. Yeah, I will explain my part. It's a mix between series and it's a parallel circuit. Okay. Uh, the first of all, as you can see, you see that in a parallel circuit where the resistors are parallel, you see that the voltage is not by. Wait, I had a problem. Go. Okay. You see that. Let's continue. You see that whenever the resistors are in parallel, you see that the voltage stays the same. However, the current is different. Is different, as you can see in the diagram shown. Compared to the series resistor, the series resistor, the voltage changes. However, in parallel resistors, the voltage does not change, the current changes. Now, if we add another resistor into the parallel circuit, you see that the voltage also stays the same. However, the current also changed. Changed once I added 25 ohms. Ohms. We can when we doubled our voltage supplies, the voltage We when we doubled our voltage supply, we see that the voltage stays the same. However, the current changed, or the current has increased. When we short circuited one of the resistors, the entire circuit was short circuited due to it being parallel. So the electron flow chose the one resistor that is short circuited due to it having low resistance. So the entire circuit is currently short circuited. And for when we remove the second resistor, the uh, you see that the voltage did not change. However, the current changed back. When adding a resistor in series versus parallel, when resistors are connected in series, the same current flows through each one, but the voltage splits between them. The voltage across each resistor depends on its value. In a parallel circuit, the opposite is true. Each resistor receives the full voltage, but the total current is divided among different branches, like I explained before. Adding batteries in series and versus parallel circuits. Connecting batteries in series increases the total voltage, in which in turn rises the current flow through the circuit. However, connecting identical batteries in a parallel does not increase the voltage; instead, increases the total current capacity, and extends battery life, which will maintain the same voltage as a single battery. Open circuit versus short circuit conditions in series and parallel circuits. An open circuit, which is a break in certain path, has a different consequence depending on the circuit design. And in a series circuit, a single open fault disrupts only available path for the current, causing the entire circuit to stop functioning. In contrast, an open circuit in parallel configuration is less severe. It only interrupts the current spec- in the specific branch which the break occurs. The other branches, having intact paths to the voltage source, continue to operate normally, allowing overall circuit to remain partially functional. A short circuit occurs when a very low resistance path is created, diverting a current away from its intended routes. In a series circuit, a short course across a component causes the voltage across the component to drop to nearly zero, which, while increasing the voltage across the remaining components through the circuit, continues to flow. However, a short circuit in a parallel branch is typically more catastrophic. It provides an easy path that draws an excessive amount of current, which often causes the voltage across the entire circuit to collapse. This voltage drop prevents other branches from operating, and a large current flow can quickly lead to overheating or damage. In the last question, I explained that to as shown in the diagram. Now, Sui will explain the third part.
Yeah, so thank you, Yaya. So now we'll go through my part. I'm going to explain about the combination series and parallel circuit. So as you can see, that this is our part C for the question. And so first, I'm going to disconnect for the R1, which is you can see from here. And then when the disconnect for R1, the whole circuit can flow with voltage and uh, current. So second, I will disconnect for the R2. So when disconnect the R2, the current can still flow and the voltage is also function, but the current will be quite small, and also the current will go through the R3. And I also disconnect for the R3 also. So as a same situation with the disconnect R2. So when disconnect R3, the current is still flow, and then the whole circuit is still functioning with a current of 0.24 ampere. So and then I also disconnect for R4. So when disconnect for R4, the whole circuit cannot function since there is no way for the current flow. So the current is going to 0 ampere. So R5. when I disconnect R5, same situation with disconnect R4, because the current is nowhere to flow, then the current will be 0 ampere. The whole circuit cannot be functioned. And also, I will also do with short circuit R1. So when short circuit R1, the R equivalent will be 100 over 3 ohm. So when I sub to the basic law, I will get I is equal to 0.36 ampere, which is same as the Tinkercad we did. So second, I short circuit for the R2. So when short circuit with R2, put a one wire between the R2, and then the R equivalent will be 30 ohm, and then V equals to IR, we can get that I is equal to 2.4 ampere, which is also the same with the Tinkercad we do. Okay, then we also short circuit for R3. So when short circuit R3, the R equivalent is equal to 30 ohm, which is same as the short circuit for R2. And when you put inside the V equals to IR formula, we can get that I is equal to 0.4 ampere, which is same as the Tinkercad we did for the situation short circuit R3. And also, we also did for short circuit for R4, which is the middle one here. And then when we calculate for the R equivalent, total ohm will be 150 over 3 ohm. So when we calculate V equals to IR, some extent formula, we can get that I is equal to 0.313 ampere. Okay, last, so we we short circuit for the R5. So when we short circuit R5, we can get the I equivalent is equal to 85 over 3 ohm. And then when sub inside the formula, V equals to IR, we can get that I is equal to 0.424 ampere, which is same as the Tinkercad we did. So this is all about our hands-on activity.